Good morning, children. Today we are going to see the first lesson in chemistry, atoms and molecules. So, what are atoms? Atoms are the smallest unit of any matter. Molecules. Molecules are a group of two or more atoms that form small identifiable units. In this lesson, we'll be studying in detail about atom, its mass, molecule, and its mass, and other calculations. How did the theory for atom come? The first scientific theory of the atom was proposed by John Dalton. After him, many other researchers like J.J. Thomson, Rutherford, Niels Bohr, Schrödinger, so all these people also studied about atom and they found some incorrect postulates. So these have been modified and we got a new theory called as the modern atomic theory. The main postulates of modern atomic theory are an atom is no longer indivisible. So atom can be divided into electron, proton and neutron. Atoms of the same elements may have different atomic mass. We all will study about isotopes in this lesson. One particular element having two different masses. Atoms of different elements may have same atomic mass. Isobars. Here, two different elements having the same atomic mass. Atoms of one element can be transmuted into atoms of other elements. In other words, atom is no longer indestructible. Discovery of artificial transmutation, transferring of atoms from one element to another element. Atoms may not always combine in a simple whole number ratio. For example, glucose is in the ratio of 6, 12, 6 or 1, 2, 1. Another example is sucrose. It is in the ratio 12 is to 22 is to 11. So they do not form simple whole number ratios. Atom is the smallest particle that takes part in a chemical reaction. The mass of an atom can be converted into energy. The formula for energy is E is equal to mc square. Atoms and atomic mass. We all know that atoms are the building blocks of matter. According to the modern atomic theory, an atom contains subatomic particles such as protons, neutrons, and electrons. Protons and electrons have considerable mass, but electrons don't have such a considerable mass. The mass of an atom is mainly contributed by its protons and neutrons. So, what is mass number? The sum of the number of protons and neutrons of an atom is called its mass number. The mass is measured in atomic mass unit AMU. Atomic mass unit is 1/12 of the mass of a carbon 12 atom, an isotope of carbon which contains 6 protons and 6 neutrons. Here we learn that atomic mass or mass number is obtained from the total number of protons and neutrons. Electrons don't have a considerable mass, so they are not taken into consideration. And the measuring unit is AMU, atomic mass unit, and they are comparing it with carbon 12 atom to obtain the mass unit. Since a single atom is very small, its absolute mass cannot be determined directly. That is, the correct value of the mass cannot be determined. So earlier what they used to do, they used to compare or relate one particular atom of an element with another atom of an element. They measure the masses of equal number of atoms of two or more elements at a time to determine their relative mass. So the mass obtained through this method was called as relative atomic mass. They established one element as a standard. So they kept any one particular random element as a standard and they were performing this relative atomic mass calculation. So in the beginning they were using hydrogen and hydrogen was replaced by oxygen, and finally we obtained a stable isotope of carbon which is also called as C12 with atomic mass 12 where proton is 6 and neutron is 6. So carbon 12 is used as a stable isotope for relative atomic mass calculation. Relative atomic mass of an element is the ratio between the average mass of its isotope to 1/12th part of the mass of carbon 12 atom. It is denoted as AR. It is also called as the standard atomic weight. Here we can see a table whose relative atomic mass is obtained using the C12 scale. Hydrogen, carbon, nitrogen, oxygen, sodium, magnesium and sulfur. They have given a small table with relative atomic mass of certain elements. Average atomic mass. It is a little complicated to calculate the atomic mass of an element because naturally occurring elements exist as a mixture of isotopes, each of which has its own mass. Therefore, when calculating mass, we even have to consider isotopic mixture. The average atomic mass of an element is the weighted average of the masses of its naturally occurring isotopes. We will see the calculations separate. So now we will move on to the theory part. Isotopes existing can be of different weight. So we have to calculate the average of each and every isotope. In the periodic table, the atomic mass of elements are the average atomic masses. Sometimes the term atomic weight is used to refer average atomic mass. In the periodic table, if you observe, they would have not given whole numbers. It will be 12.01, 15.999 because it is all average values. For example, the atomic mass of carbon in the periodic table is 12.01 AMU, not 12.00 AMU, because carbon can be as carbon 12 as well as carbon 13 are taken into consideration, and when they are calculating the average, it will come up to 12.011. So, we have to understand that the atomic mass of carbon is 12 AMU. It refers to the average atomic mass of the carbon isotopes, not the mass of the individual atoms of carbon. Molecules and molecular mass. Except noble gases, atoms of most of the elements are found in combined form, or else 2 or 3 atoms put together. This is called as molecules. A molecule is a combination of 2 or more atoms held together by strong chemical force of attraction. The chemical forces of attraction are also called as chemical bonds. Classification of molecules. A molecules may contain atoms of same elements or may contain atoms of 2 or more elements. This means molecules can be either elements or compounds. If the molecule is made of similar kind of atoms, then it is called homoatomic molecules. If the molecule consists of atoms of different elements, then it is called heteroatomic molecules. A compound is a heteroatomic molecule. Atomicity. The number of atoms present in the molecule is called its atomicity. Let us look at this table, classification of molecules. According to the number of atoms present, the molecules are classified as monoatomic, diatomic, triatomic and polyatomic. If the number of atoms present is 1, so that time it is monoatomic. If there are 2 atoms, then it is diatomic. If there are 3 atoms, it is triatomic, and if it is greater than 3, it is 4 and above, so that time it is polyatomic. An example is oxygen. Oxygen can exist in 2 allotropic forms, oxygen O2 and ozone O3. In oxygen molecule, there are 2 oxygen atoms. So the atomicity is 2, and since the atoms are similar, it is homodiatomic molecule. Some more examples are nitrogen, hydrogen, and the halogens, fluorine, chlorine, bromine, and iodine. These are all examples of homodiatomic molecules. Homotriatomic means same type of atoms, but there are 3 atoms together. Example, ozone. O3 contains 3 oxygen atoms, so it is homotriatomic molecules. Heteroatomic molecules. An example is water, hydrogen chloride. Here, 2 different atoms exist together because of the chemical bonds H and Cl, hydrogen and chlorine, and in water you have hydrogen and oxygen. You have 2 different types of atoms. Relative molecular mass. As molecules are made of atoms, they also have their own mass. The mass of a molecule of an element or compound is measured using the same C12 scale and it is called as relative molecular mass. The relative molecular mass of a molecule is the ratio between the mass of the molecule of the substance to 1/12th mass of an atom of carbon 12. The difference between relative molecular mass and relative atomic mass is only the word molecule and atom. The relative molecular mass is obtained by adding together the relative atomic masses of all the atoms present in the molecule. Difference between atoms and molecules. Atoms. An atom is the smallest particle of an element. A molecule is the smallest particle of an element or compound. Atoms do not exist in free state except in a noble gas. Molecules exist in free state. Except some of the noble gases, other atoms are highly reactive. They react at once. Molecules are less reactive because they already have chemical bonds to make it stable. Atom does not have a chemical bond. Atoms in a molecule are held together by chemical bonds. Okay children, in the next video we will see about mole concept. Thank you.